We're going to begin Unit 2. So Unit 2 is on logic, and logic is a difficult topic to teach to someone because it's really about how your brain processes information. So some of us just naturally, it just makes sense. You enjoy puzzles, you enjoy doing those just Sudokus and all the different curious puzzles, like when we've been doing these math talks and you've had to move the matchsticks around or solve and look for the nitty-gritty details. That's really what logical reasoning is. If those have not been as enjoyable to you and you like things told to you, then it's a little more difficult sometimes to teach someone to be a logical thinker. So we're just going to start with a little bit of vocabulary. So the first vocabulary word that we're going to introduce to you is something called a conjecture. So what a conjecture is, it's really just a fancy word for it's your guess based on what you've observed. So there's no proof that you're correct. It's just kind of your opinion. Conjectures happen all the time. You're watching somebody walk by you on the street and you make an observation and you make a guess about them. You might be right or you might be thinking a rumor. So those are all conjectures. It's just, I think that's true. Sometimes they're true and sometimes they're false. Inductive reasoning is where we usually have a pattern in front of us. And so that pattern can be a visual pattern. It can be, I've seen this happen for the past 3 weeks, so I expect it to happen again next week. It's just, you've seen something repeat over and over again that it's going to continue to happen. And so then you create a conjecture or a guess as to what's going to happen next. It's not a 100% guarantee, but we think it's going to happen. It's very likely. So for an example, if I give you a set of number patterns. So if I start with a simple number pattern that you know 1, 2, 3, 4, 5, 6, you know that 7 should come next. 8 should follow. 9 should follow that. When I look at this pattern that I have in front of you, I've jumbled up the numbers. So I start with 10, go to 7, go to 9, go to 6, go to 8, go to 5, go to 7. It's not in the order that you're used to. So what you then have to do is start digging deeper and think about what number should appear next. So pause the video and think for a second what you would think the number was, and then I'll tell you for sure what I expect the number to be. So what'd you guess? So let's talk about what I see in the picture. So I look at this in a couple different ways. I can first look at it and say, well, I see that every other number is going 10, 9, 8, 7. And then every other number here is going 7, 6, 5. And so if I were to skip, I would guess the next number to be a 4. Is that what you guessed? Now, another way you might have looked at it, you might have said, well, this from 10 to 7 was a subtraction of 3. From 7 to 9 was an adding of 2. From 9 to 6 was a subtraction of 3. Then it added 2. And you might see that that pattern continues. And so then we would subtract 3, and 7 minus 3 is 4. Both of those are observations. The first observation was simply visual. The second observation was a little more mathematical. You may have seen a different observation. Everybody processes it a little different in their brain. So now let's look at the stars. So let's look at some shapes. So I want you to draw the next shape in the pattern. So likely it's going to be a star, but you might see that there's some shading in here. Technically there's different color shading. Because this is black and white, you don't see the colors, so we'll just go with the gray shading. So I know that there has to be a star involved, so I'm going to draw myself a star. But now I need to think about what parts of that star are going to be shaded. So again, pause the video and think about what you see and who you think should be shaded in that star. Okay, let's check and see what you got. So I notice when I look from star to star to star, all the centers always are shaded. So I'm going to continue to shade the center because it doesn't look like that's about to go away. But what I am noticing is the first one started with 4 of the, I'll call them petals of the stars or points of the stars. Then I went to 3. Then I went to 2. So likely there should only be 1. Now I have to decide which one. Well, this far right one was shaded in the first one. Then it was removed. The top one was shaded. Then it was removed. And it's going around the shape in a counterclockwise position. So my guess is that this left one is now going to get removed because they were removing them as they went left or counterclockwise around the shape, leaving this bottom right or bottom left to be the only one remaining when all is done. So that's what I would expect the next shape to be. If we were to continue one more time, likely this side is going to be gone and we'll be left with the center. Now, if I said, well, then what would be the next one? We could go into debates. Would that center then remove? Or does the pattern stop? We don't have enough information to go there. And that's where inductive reasoning can sometimes not have enough information for you. So another vocabulary word to talk about is something called a counterexample. So how a counterexample works is it's where you're going to prove that that conjecture is false. It's like when you're at school and you hear a rumor and you go up and you tell them you are spreading false rumors. Same idea. That's what you're trying to do with a counterexample. You're trying to tell somebody why they're wrong. Students love to do this to teachers. You love to prove us wrong. And sometimes teachers like to give it back a little bit. So when do you use a counterexample? So you can prove a conjecture if we know that it's always true, but that's hard to do, that it's always true. But it's really a lot simpler to prove somebody's false because you just find one example that proves them wrong. So sometimes you hear these statements, and I hear them a lot of times as a teacher, that you'll remember things falsely. There's often this statement called a Mandela effect, where we sometimes think we hear what we hear, but it really isn't. If you haven't ever heard of the Mandela effect, you should Google it and watch a YouTube video. They are very interesting because it talks about what we sometimes think we hear versus what we really hear. The idea of when you hear the word Fruit Loop, if you look on the front of the box of a Fruit Loops, how is Fruit Loops really spelled? Is it spelled like the word fruit, or is it spelled with F-R-O-O-T? Look it up. Okay, so let's talk about the counterexample here. So if you want to disprove each conjecture, we're going to read the sentence. Any 4-legged piece of furniture is a table. Is that true? Well, to a young child, possibly, it could be true. But hopefully you would say, well, I am sitting on a table or sitting at a table. It does have 4 legs, but I have chairs in my classroom that have 4 legs. They are not tables. I have a sofa that has 4 legs that stick down underneath it. They're really small legs, but they're still there, and it's on my sofa. So if you can give me an object that has 4 legs, that is a piece of furniture, but is not a table, that's considered a counterexample. So you're finding something other than a table. So you're trying to prove that table is necessarily false. It could be a chair. Or a bed. Or a couch. Just because it has 4 legs and it's a piece of furniture doesn't mean we're going to use the word table. How about the second example there? Everything in the house with hands is a clock. Again, those are assumptions, especially when you're beginning vocabulary words, especially when you're a child, learning what words mean. Sometimes we make false assumptions. So what else in a house has hands that's not a clock? Hopefully, you thought about the people living in the house. They have hands. They live in a house, but they're not clocks. Okay? So you might have come up with some other thought process for something else that has hands that lives in a house. So those are what counterexamples are. So counterexamples are when you are finding something that can prove a statement is false. And we're going to stop with those vocabulary words. Seems like a very small amount, but those are a bunch of vocabulary words that we want you to practice with.